Hey guys, welcome back to Rocket Gyan, my fellow space tubers. Okay, so today is a very big day indeed because the most awaited small sat launcher is going to make to the orbit today. I mean, yes, that's what our hopes are right now, right? They will make to the orbit today, and this is their kind of fourth flight in which they will be trying to making their orbit today. So I have a lot to talk about. There are things to, see also how the rocket looks like and how it will perform. So, without any further ado, we will just jump into it. Okay, so how are you all, guys? Hi, John. Hi, Thinking Sail. Okay, hi, Amir. Amir, okay. The flight is not confirmed yet. Yes, I mean they haven't, officially declared anything, but we do have the official live stream. I mean, up at the time because they said they will go at around T minus 60 minutes until the launch. So kind of you can say we are still on for the launch today. Uh, let's see. They still have a backup window for tomorrow and day after tomorrow. So yeah, let's see what happens. Okay, so for this flight, let's have a look at this. First of all, this rocket. This is a very small launcher, I must say that, because first of all, it comes into a category of electron only, but the payload which this rocket can take into the orbit is very less. I mean, the maximum payload capacity right now it's just 25 kilograms, and they will be improving it to around 150 kilograms in future. So you can say the range will be around 25 to 150 kilogram. But that is not the thing. The payload capacity, if it is less, it is for a reason, because they are catering to the small, very small set market, cube sets basically, because they only tend to weigh around that in that range only. So it's okay. Their goal is to be able to have a turnaround of just 24 hours after relaunch, and hence they can launch according to the demand. So this is their vision or motto, whatever you want to say. This is how their rocket look like. Yes, this is a steel body what we have seen on the Starship, and this has the second stage and the payload itself. And this launch is from Alaska. So yes, it is a mountainous region, as well as it is a icy region. Yeah, since it is in a mountainous region, so yes, they get an what should I say, benefit of ISP of launching from higher altitude, but again they have to compromise with the productivity of the employees, because you know colder icy temperature is not very suitable for any person to work for. So for today's launch, they are going at a 70 degrees inclination. So kind of you can say sun synchronous orbit, altitude of 415 kilometers, and this will have a non-deployable Space Force payload. Okay, so they are right now not deploying because Space Force just actually signed the contract with them in which they had to launch 2 times successfully before any payload can come onto it. So that is the thing, and this is the flight sequence. You can see that it will be around 8 minutes and 30 seconds of total flight. About we will have at the rocket also. Okay, so yes, let's have a look at the rocket now. Okay. Just a sec. I have a good things for you. Let's hope. Yes, hi Rocketgan. Can't wait to see this launch today. Yes, I'm too excited for it. Okay, let's have a look at their this rocket. Okay, I do have some animations for you to see how the rocket would look like. So there you go. Thanks to Rocket Explorer, here we are. So this is a rocket 3.0. This is what they have named it, but today their rocket will be rocket 3.3. Okay, so uh, just a sec. So this is a rocket 3.0, or you can say rocket 3.3, and there is not very much difference. And talking about the payload capacity, I've already talked about the payload capacity, so that is that. Okay, And let's explore this rocket. So first of all, the first stage comprises of this 5 engines. You can see here, these are the 5 delphin engines, that as they call it. It produces a thrust of around 147 kilonewtons, and they are pump fed, electric pump fed engine, which means they are similar to what electron uses for its cycle, electric pump fed. And yes, the fuel is also same, the rp1 and lox. So this is the first stage. Now let's have a look at their second stage. So here you can see, this is how their second stage looks like, and it is, you can see right now, it's very, most of the part is taken up by the rocket, and then this is taken up by the second stage, and the second stage is very small. Here you can see this. Let me just so you can have a proper look at it. So here you can literally see that they don't have anything, literally two tanks attached together, and engine, and yes, a big nozzle for vacuum optimized thing, and then a fairing will house the payload. So here you can see, actually, this is not a very complex second stage, because this is simply a pressure fed engine, that's it. There is not any complex thing going on here. That's why you can see also the engines are also like kind of very um simpler, because they only need two connections. I mean, the fuel, the oxidizer, and the what should I say, the fuel, and they makes it ignite and then happen. The pressure fed engine, it produces a thrust of 3.1 kilonewtons, and yes, it also has the fuel of rp1 and lox. So I guess this is the thing. Can now see it properly, I guess. Did you like this thing? Should I include such a thing in my future launches also? Do tell me that. Okay, if you have any other questions, you can ask me and I will try to switch to the stream is up. Okay. And we can also visualize it by looking at the scale also for this rocket. I mean, this rocket is just 43 feet. It's not a very big rocket. This is designed for having, just 7 days of preparation time, and 24-hour turnaround time they want to have for this, their vision. Also, the cost per launch, since this the payload capacity is also very low, and this rocket is does not have any complex mechanisms also, so therefore the cost per launch comes down to 2.5 million dollars per launch. That's it. This is totally revolutionary, I must say that, for CubeSats. Okay, how tall is the rocket? I just answered. Cool. So let's see if we have any other note. Okay, let's do have some. Okay, let's have a look at how the will it look, means the scale of this rocket. Okay, so if I just load it, here is the rocket. Rocket is not here, right? Okay, let's have a look at how the rocket will look like in kind of this vehicle assembly building and a hangar. Not a hangar, but okay, you can say that. Uh, there you go. Let's go down and see it up close. See the scale also. How does it look like? Hey, you can see now. This is a small rocket. A person is just standing here, and you can actually see the scale also because of this. The average human being standing here, and this is the rocket. I can't go inside it obviously, but this is the Delphin engine, the 5 Delphin engines. The second stage here, and the fairing here. So this is a very small, not a very tall rocket. 42. let's move on to the stream now. Heck. Give me a sec. Just let everything is going. So we have T minus 54 minutes until the launch. Yes. Guys, bear with me just a sec. I'm facing a glitch here, but just bear with me. I'm switching. Won't miss out anything. Just bear. Okay, in the meantime, if you have any questions for me to, ask, you can do that by the time I figure out what is going on here. That, okay. This glitch we won't face on in the next stream. This is the thing which when today only I'll be prepared the next time. But just a much kgs can it take to the orbit? The kgs which it can take is around 25 kilograms right now, but it is expected for them to go till 150 kilograms. That is that. Now it is working fine.
Orbital launch vehicles in the US. That's where LV-6 will launch from today. And we'd like to take a moment now to thank all of the PSCA team for being an instrumental part of our launch and continuing to help us safely and efficiently operate in beautiful Kodiak.
First of all, guys, I would like to give a huge shout out to NASA Spaceflight for providing this stream. And yes, you have it right now, and you can see the rocket in front right now on the launch pad. We have 51 minutes until the launch, and let me see why is it buffering.
And that is the opening of a window, and as you can see on the screen, with the one watch item we are looking at is winds, but I believe right now everything is tracking on time for launch. Is that right?
That's right. So far, we are moving smoothly through our countdown procedure.
That is great to hear. You will also be hearing the countdown net as the launch controllers go through their various procedures. You'll hear that every once in a while. That'll give another update on how the countdown is progressing. And as we look at mission control here in Alameda, I'll point out, well, one of them has stepped out. I'll point out the launch conductor, which is Charles Hoffman in the Mohawk in the back row there. He will be joined on his right shortly by launch director, Chris Thompson. And that is the half a dozen or so folks here in launch control in Alameda, and they are joined by another crew that is similarly small out there in Kodiak, isn't that right?
That's right. We have our red team of is working very hard to stay safe out there, and we want to thank them for all that they do to help us operate so efficiently.
Will
Okay,
be able to see
so
the teams hard at work today, and what we're also seeing now is the beginning of propellant load operations. Just before this stream started, the teams pulled go for propellant load, and you can see the rocket starting to get frosty on the outside. Let's talk a little bit about that. The Astra Rocket 3 series is fueled by kerosene and liquid oxygen. The kerosene is ambient temperature, which is why you're going to see that frost line kind of partway up the rocket there, not the entire rocket, because only the liquid oxygen tank, which is on top, is going to cause the air around the rocket to condense, and you'll see that ice forming on the outside, as we see with many, many launch vehicles that we watch here at NASA Space Flight. And as that frost progresses, we'll get that visual indicator of how fuel load is going. And that will continue until just a few minutes before launch. Diving back into some more questions here, we have one asking about
okay,
potential
so
future reusability.
let's have
I don't believe Astra is going to go that route. Can you talk a little bit about why, Carolina?
Right, we are focused on producing expendable rockets. There's a few reasons. One is just from a physics perspective, you have to carry extra mass to make a rocket that can withstand reusable flight. And we also get economies of scale as we make more and more of the same type of rocket, since we can save that refurbishment cost. And finally, we are designed our rocket as a small rocket that is not designed to be carrying people. We're sending payloads up into space. And so we want to focus on making something as efficient and simple as possible. One of our values here at Astra is that simple scales. So we don't want to add a lot of mass and try and reuse things and build in that extra engineering work. So expendable design, we believe, is going to be the path to help us get up to scale.
That simple scales philosophy is written all over the place here at the factory. You see it everywhere. And those simple, small launch vehicles that you can mass produce to the point where your serial number needs three zeros at the beginning of it. So you have room for all those future rockets.
So talking about
Absolutely.
what cargo they are carrying right now, they are carrying the United Space Force payload. That's a mass simulator kind of a thing. You can say that because it will not deploy, and maybe it can have some scientific equipments or some instruments which United Space Force want to test. But right now, the payload capacity for that, means the weight for that, would be around 25 kilograms. So that is that. So everything is looking good. We are good for the launch. We can see the countdown is progressing well. Only thing is the weather right now, but let's hope this increases and improves.
Now joined by Chris Thompson to his right, our left. Those are your launch conductor and launch director for today's launch.
And okay, let's just have a talk about their previous launch attempts also. Okay, so
As the
previously
countdown
they
proceeds,
have
and we're going to let some more questions come into the
they
queue,
have
Rocket
rocket 3.0, 3.1 and 3.2. This is the 3.3 they are launching. Unfortunately, all of them had some issues, and none of them actually made it to the orbit. I remember 3.0 had some issue during the ground only, and it was not successful. Then the 3.1 rocket had some issue, I mean the software issue, so therefore it lifted off from the pad, but after 21 seconds the FTS, the flight termination system, activated and it was destroyed. So talking about the 3.2, that was their most successful one. They literally kind of, you can say, reached to the orbit, but they were short of around 500 meters per second of velocity. And the first stage performed well, the second stage performed kind of, you can say, well, but they still did not reach to the orbit with the I mean, they were short of around 500 meters per second. The reason being their fuel to oxidizer ratio, the mixture ratio, was not the that optimal account. So therefore the engine was not able to perform that well. And this is a pressure fed engine, and in pressure fed engine the mixture ratio kind of plays a very important part. And that happened there. So that's the reason why they were not able to reach. Otherwise the system performed properly. The fuel oxidizer mixture ratio had some issue with. So now they have, in 3.3 flight, what they have done is they are first of all confident that this will make to the orbit. Okay. And Second of all, they have improved obviously the fuel to mixture ratio for the second stage, and even the first stage they have stretched the first stage to increase the amount of fuel it can carry. So basically, increase its performance. Yeah.
And right now we're looking at rocket 3.3, that version of Astra's rocket. Can you talk a little bit about how the previous versions of the rocket that we've seen fly before have been upgraded and changed to get to this version?
Absolutely. So this is our latest and greatest rocket. What we have done in the time since our last flight in December, we first of all fixed the issue that caused us to fall short of orbit. So that was an issue with our propellant mixture ratio. We've resolved that issue. We've also extended the first stage tanks in order to allow more propellant to load onto the vehicle so we can get more payload. And we've also consolidated a lot of the components on the upper stage in order to, again, get more payload capability out of our rocket.
And this is still a dedicated small launch vehicle, and we've got a question in chat asking if Astra has any plans for a bigger rocket after this.
Yes, our rockets may get a little bit bigger as we proceed and adjust our plans for our customers. We are, of course, looking to serve what our customers' needs first and foremost. And we've made changes and continue to improve on our rocket. Our Rocket 2 was smaller than our Rocket 3. We increased the diameter, and we'll continue to make small iterations. It's a big part of our philosophy at Astra to make iterative changes and improvements in order to best serve what our customers need.
I believe that it was a length change, right? That first stage got stretched a little bit for extra propellant.
That's correct.
Countdown is proceeding. I'm going to keep coming with some questions here. We have a question asking what material is the structure of the rocket made out of?
Yeah, most of the rocket that you see here is made out of really simple materials. We tend to shy away from things like carbon fiber and 3D printing as much as possible so that we can mass produce it and continue to scale. A lot of what you see comes in as sheets of metal into our factory, and our incredibly talented machine shop team turns that into the vehicle that you see today.
And we can see that bare aluminum on that first stage looks really, really cool. It's a cool looking rocket.
Absolutely. I'm a little biased, but I agree.
So we're looking at Kodiak right now, and we have a question asking if there are other launch sites currently being considered. What kind of things does Astra look for in potential launch sites?
Yeah, again, we're looking to serve our customers and the needs that they have, but we are identifying new launch sites in the United States, and that's what we can say about our plans right now.
Okay.
What kind of orbits are you able to access from Kodiak with this initial launch site?
Yeah, we're looking at high inclination orbits like sun synchronous orbit, which is a location that many of our customers want to go to.
I know this particular flight is going towards a 70-degree inclination, so not quite polar, but a high inclination orbit, just going up to low Earth orbit, 415 kilometers altitude, and that'll be that target orbit for, again, that mass simulator payload on the upper stage, which will not be deployed in any way, just a test payload to demonstrate Astra's orbital capability.
That's right.
Is launching from.
So how did this rocket get up to Kodiak?
Alaska.
We're here at the factory here in Alameda, California, and well, it's not super close to Kodiak, so how did that rocket get up there?
Yeah, one of, I think, the most unique things about Astra's launch system is that a lot of what you see on your screen fits inside standard shipping containers. So if you joined us at the top of the broadcast, we had a video of our static fire test that showed this exact same material being deployed to our test site a couple of hours away from our headquarters. We literally load everything into shipping containers and truck it out and ship it out by boat to where it needs to go. It's something that allows us to be extremely responsive when we're setting up a test site or a launch site, and one of the reasons why the Space Force was excited to work with us.
And that rocket, all the hardware that goes around it, and the red team, which travels out to the launch site with the rocket, arrived there just a week before this launch attempt, right?
Right, just about. It is a very precise orchestration of getting everything set up, but we are able to do it very quickly.
And that's part of not only the simple scales philosophy, where you want to keep your launch teams and the hardware involved as simple as possible, but also the ability to launch from anywhere, or at least anywhere with a concrete pad and an internet connection, right?
That's right.
and as well as that quick launch
Talking
turnaround.
about
Because
that,
again, NASA is the
what
ones,
should
they
say,
achieve that
a
daily
telephone
launch
pole.
cadence. You don't
Okay,
want to be
so
off of that for weeks at a
this
time.
rocket may perform the Baumgartner maneuver. We'll have to wait and see because we haven't actually seen the proper launch footage. And if you talk about what is basically Baumgartner maneuver, that is kind of, you can say, you can say not extremely pitch, but just after the liftoff, the vehicle kind of pitches to the right or left, wherever it wants to go, so that it moves away from the launch pad and it does not destroy the launch pad. This is like a slight just a small pitch which it has to do, so as to it goes away from the pad and all those plumes does not
And I
hit that.
know that seeing some
Let's
of the
see what
characteristics,
happens
saw
in this.
that static fire video, we've seen video from prior launches, and that water deluge system is dramatic and very visible, so we'll definitely be keeping an eye out for that. Keep your questions coming. Again, tag us with @NASA Spaceflight if you have more questions for us in chat. In the meantime, let's go ahead and listen back into the countdown net as the countdown proceeds.
And guys, if you have any questions, you can definitely write on that, and I'll try my best to answer them. So right now, everything is looking great. They are still looking in for the, you can see, watching the winds and the launch attempt. So that is the thing which they are kind of looking for right now. But you can actually see the weather. It looks perfectly fine. But again, this is a mountainous region, so can't actually, and it's a very open region. Uh, Talking about the launching from the mountainous region, does it have any benefits or not? Okay, so how much is the thrust? Okay, let's just answer that. So this is powered by 5 Delphin engines. Okay, and they are what should I say, no, electric pump fed, and the fuel which it uses is RP1 and LOX. So total thrust which it produces around 147 kilonewton, and the second stage produces around 3.1 kilonewtons. And the reason being, just for the second stage, obviously, that it is very small, very 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 small, and we can see some gassing there, just clearing up the pipes, detanking. We'll have to wait and uh, it's not actually coming out from the rocket, so it's not detanking, I guess. They are clearing out the line. We'll wait and see what is happening. Okay. Yes, they do mess up with the vents. How heavy is it? Okay. How heavy is it? I can tell you how tall is it. It is around 43 feet. So that is how tall it is. And talking about how heavy it is, let me just look at a sec. And let's hope they make it to the orbit this time. Because this will be very interesting to see.
And joining me now is Dr. Adam London, co-founder and CTO of Astra. Adam, thank you so much for taking some time to join us today.
Happy to be here. Exciting day.
So how are you feeling about today's launch attempt?
We're excited. We're ready to do this. We spent a lot of time getting our rocket ready, and now is the time to see how it goes.
So what are your responsibilities here as the CTO of Astra?
I lead sort of the overall technical decision and architecture of the vehicle, and also help work on advanced technologies.
And talk about some of those upgrades. We're coming through Rocket 3.3, first launch of this version of the rocket, and there's been some upgrades since 3.2. Can you talk a little bit about what's changed for this launch?
Sure. Our first focus was making sure that we understood and fixed the issues that caused the previous rocket to not quite make orbit. And so we've addressed the fuel consumption and mixture ratio control situations. That was one thing. But in addition, we made other improvements, including lengthening the rocket a little bit, so it's about 5 feet longer than the previous one, as well as improving the performance of the upper stage.
And how do you balance making those kind of upgrades and tweaks when you learn from every single flight when you have several rockets in various stages of production at any one time?
It's tricky, but we try to, ultimately, our goal is to build batches. And so the next rocket, LV0007, is on the floor over here getting built. And if this rocket goes well, it will be an identical copy. If from this rocket we learn things that make us want to change a few things, we'll make some small changes in it and continue moving along in that direction.
Cool.
And how is
Sounds
Astra
interesting.
currently working today to transition not just between launches and learning from every single flight, but also transitioning towards your future rockets, maybe scaling it up to larger payload capabilities or bringing down launch cadence time so you can eventually achieve that daily launch cadence?
Yeah, a lot of what we're doing now is thinking about production. And so the Rocket 3 series will be the one that we first produce at rate. And so 0007 will be next, and then 0008, 0009. In that process, we'll be learning and taking those learnings to apply them to future improvements of the rocket.
I'm going to take a question here from chat here. They want to ask Dr. London, what is the most fun part of rocket design? Because I know you have some very interesting rocket design programs in your history.
The most fun part is always watching the rocket's light, either the engines in the test cell or the rocket as it's getting ready to leave the pad.
And lastly, I want to ask you one last question before we let you go. On launch day here, thank you so much for joining our sort of pre-launch, pre-game interview. Once we are getting close to T0, what are you going to be doing and where are you going to be watching the launch from?
Well, once we get to T0, there's not much we can do. The rocket flies itself, and so I'll be sitting there with the rest of the team, enjoying the video and watching the data to see how it performs.
Adam, thank you so much for joining us. We're all looking very much forward to this launch, and best of luck to you and the teams. And just, yeah, thanks so much for taking some time with us today.
Thanks for being here, and looking forward to seeing this flight.
All right, let's listen back into the countdown, Ed, as the countdown proceeds past T-minus 33 minutes and counting.
Okay, so we are looking great here, and let's have a look at the questions. And talking about how heavy is it? See, this is Astra is actually kind of very secretive company, because you can kind of say this company was founded on the basis of one competition with which United Space Force launched, and that's why it's kind of very secretive. Not too much is known about this thing. So right now we don't know how heavy is it with the dry mass or wet mass, whatever you want to know. So next is I've heard that Astra is working on developing a sea launch capability. What modifications would be necessary to make that work? I guess first of all, I didn't hear whether they are launch capability, but since this is a very small rocket and this does not require any complex transportation techniques, as she said, can be transported in just a shipping container. That can very well go onto a ship. They don't even require a very big ship like the SpaceX Starship. No, not at all. They can go that sea launch capability can happen with the small ships also. Talking about the modifications, well, right, this rocket is kind of, you can say, designed keeping in mind the mobile launch capability. So the mobile launch pad is, you can say, the distinguishing factor for this rocket. So it has been designed keeping in mind that, but right now it does not launch from a mobile launch pad. Okay? So since it is already designed according to the mobile launchpad, so I don't think so we would be require much transformations as such, but we could see some changes in the flight sequence so that the ship basically does not have some take the damage after it launches, like silo launch. I don't think so this will be silo launched, but why the rocket is silo launched from the ships.
And
Because
Carolina, let's talk a little bit about why that countdown
okay.
is a little quiet right now. Sounds like things just might be going really smoothly.
Yes, we are at T-minus 31 minutes now, and things appear to be proceeding nominally.
We always love to hear things are going nominally. We'll keep listening in every once in a while, but sometimes a quiet countdown net is a good countdown net, meaning the teams are talking on other nets to resolve any minor things, but sounds like no major issues being worked at this time.
That's right. No news is good news at the moment.
Absolutely. And we're coming up on that T-minus 30 minute mark. Again, if you're just joining us, liftoff is targeted currently for 2 p.m. Pacific time, and we'll give you any updates if that changes, but so far the countdown proceeding nominally. And we're going to keep going through some questions in chat, so if you have more of those questions, throw them in the chat, tag us with @NASA Spaceflight, and we're going to keep answering those as best we can. So let's talk a little bit about how far away launch control is from the launch pad, the pad up in Kodiak, Alaska.
Well, you can see the pad up is in Kodiak, Alaska, and our launch control is actually right behind us here in our headquarters in Alameda. So it is very, very far away. We have our team at Kodiak, the red team that helps to set up and prepare everything for launch on site. They have fallen back to a safe distance from the pad, but our launch control is entirely here in Alameda. We have our mission control camera that you've been seeing, and we also have the team of engineers who has worked on the system and is looking at data dispersed throughout our factory.
And that red team, which has backed away from the launch site, obviously now that we're into propellant load, is not actively controlling the launch then. That's all on the people sitting behind us here in California.
Right, the vehicle is entirely controlled from our launch control here in Alameda.
Oh. So talking about the purpose of this mission, this is kind of, you can say, a
Here
technological
in Alameda,
demonstration.
it's not just mission control. We're in the middle of a giant factory space. Does all of the manufacturing still happen here in California?
Yes, actually, all of our manufacturing still happens here at our headquarters in Alameda, and we also do a bunch of our engine testing here on site as well. It's pretty amazing to see an engine built on a benchtop and rolled over to our test facility literally across the road on the stand and fired off in the same day.
We definitely appreciated the opportunity to get a tour of those factory and test facilities last week prior to this launch campaign, and we're looking forward to sharing that on the NASA Spaceflight channel, so stay tuned for that on NASA Spaceflight on YouTube. In the meantime, 28 minutes and counting, teams continuing to count down towards the launch of Launch Vehicle 0006, Astra's third orbital launch attempt. I want to talk a little bit about the teams that have built this rocket, tested this rocket, and are now conducting the launch attempt. While around here in Alameda, we've seen a lot of people coming from a lot of different backgrounds. Even at the high VP level, there's a lot of people coming with maybe not even aerospace experience, coming from a lot of different industries. Can you talk a little bit about how that makes Astra a bit of a different rocket company?
Yeah, absolutely. You know, we're here in the San Francisco Bay Area, which is not a typical place where you find a lot of rocket manufacturers. So we like to take advantage and try and think differently as we're trying to build a rocket in a way that no one has ever built one before. So we do have a lot of folks who come from Silicon Valley companies. We have folks from the automotive industry. We really value that diversity of thinking as we try and build differently.
And we have a question in chat about someone who may be potentially looking to join that team, wondering if Astra has an intern program?
Yes, we do love having interns here at Astra. You can learn more at our careers page on the Astra website. But we've had, as our summer's wrapping up, we've had a wonderful group of interns that have just wrapped up their summers, and we hope to welcome many of them back.
Excellent. Another question in chat. Again, we are targeting a liftoff time of 2 p.m. Pacific time, but a question asking how long does that launch window remain open for? Because that's just the opening of today's attempt.
Right. So if we're, for any reason, have to scrub today's launch, we do have launch attempt, our launch window extends through September 11th, so we have plenty of chances to try again. It's not an instantaneous window, so we'll have a few hours, but we do know that the wind is looking best at the beginning of our window, so we're hoping to light that candle at the very start of our window.
Sounds good to me. Again, 26 minutes and counting to the opening of that window. Teams monitoring winds, but otherwise everything tracking on track for launch. And again, keep those questions coming into chat. Tag us with @NASA Spaceflight, and we're going to keep them coming till we get to that business end of the countdown. To preview a little bit, I believe we'll get into that terminal count bit just about 15 minutes from liftoff. So we're just over 10 minutes away from things really kicking into high gear here.
Okay, so good right now. Everything is fine.
In the meantime, let's go ahead and listen back into the countdown net as the countdown proceeds.
Okay. Now, guys, you can ask me also the question, and I was answering mobile launch pad. So yes, right now we won't see any as such, differences, modifications for the rocket, but we could see some differences in flight sequence, and most of the changes would be in that ship or whatever. Yeah, the ship it is carrying. So yeah, that is. What's the probability of success launch? 30%. Right now it is 0%. You can say that because this has not been successful yet. This has been launched 3 times in the past and it was not successful, but right now they are very much confident that they will achieve all the objectives, because the last time they did achieve almost every other objective, but the second stage had some issue with the fuel mixture ratio, so
Config update in 30 seconds.
the efficiency of the engine decreased and they were short of around 500 meter per second to achieve the orbit. So they hope to improve that, and they have stretched the tanks also of the first stage to gain in some payload capacity. 54 minutes until liftoff. The mission control is looking good. So this type of mission control with so many screens in front of them, like 3 screens for one person monitoring everything, is kind of cool. I must say that. It
LC ether countdown ready for config when you are.
okay. So looks. So what is the objective and what are the measures of okay, they're talking about the objectives. This is kind of, you can say, a technological demonstration that they can achieve the orbit without any problem. So they do have some payload going in, as they say, the mass simulator, but I highly uh, you know I don't believe them. I guess, because that mass simulator, whatever is going, is from US Space Force. So uh, you can kind of say that that would be sort of experiment or instrument going, which is not deployable. So the whatever the payload is going, mass simulator as this is not deployable, so it will be attached with the stage, and yes, that is their mission. Talking about the success, right now they want, they are saying that they are very confident that they achieve with this mission, because they have already eliminated most of the problems which they faced earlier. So yeah, let's see, and let's keep our hopes high, and uh, um, let's be optimistic. What environment is the engines tested in? Vacuum chambers? What heat? Maximum altitude roughly? What heat? Um, Talking about the testing of the engine, can see when the engines are made. Okay, so first of all, talking about the first stage engine, the first stage engine has to from the atmospheric region, a highly dense atmospheric region at the surface level, to a very low dense atmospheric region around 60, 70 kilometers above the surface. So what do you do? How do you design the first stage perform optimally throughout the flight? Is you actually take the average of the heights, right? Means the average, 60 divided by 3, wherever you are kind of separating your first stage, you take that altitude divided by 2, and at that altitude, whatever the answer you are came up with, at that altitude you try to design your engines, because you want that the engines should perform optimally throughout the flight. So you kind of take an average, and you design your engines in such a way that at halfway through
And
the
Carolina, I
flight for
think
the
we have an
first stage.
update on the countdown as it progresses.
Yes, absolutely. Things
Okay,
are moving right along. We have word that we will likely enter a hold at T-minus 20 minutes for a few minutes while the team spends some additional time on software configurations, but everything is proceeding nominally at this time.
Yeah, and we'll stand by for a new T0 once that hold clears. Again, coming up on a hold in just over a minute as teams continue to just make sure the rocket is 100% ready to go. In the meantime, we have more questions, so we're going to keep those coming. And let's talk a little bit about engines and propulsion. This rocket, I believe, has 5 engines on the first stage, 1 on the upper stage. Can you talk a little bit about those?
might get some
Yes,
answers.
absolutely. So our engines on this vehicle are all designed and built in-house by Astra. Our 5 first stage engines are electric pump-fed engines. We call them Delphins, and they each produce about 6,500 pounds of thrust on the first stage, and there are 5 of them. And then on the upper stage, we have a pressure-fed ether engine, which is about 700 pounds of thrust. and both stages use the same LOX kerosene propellant.
And is there a reason that Astra chose that particular propellant combination for Rocket 3?
We like to use things that are simple and efficient, and this was the right choice for this vehicle.
Gotcha. Again, we're coming up on T-minus 20 minutes. You're going to see that clock hold for a little bit. Team's just working through some final pre-launch checks.
Got it. Hold enough.
And there is that hold. In the meantime, let's talk a little bit about the history of Astra. This is the first live broadcast, and of course here at NASA Spaceflight we are very honored to be allowing us to share that with the world. And but let's talk a little bit about how Astra got here. What led up to today's launch attempt?
Absolutely. So Astra was founded in 2016 as a different kind of space company. We were in stealth mode for several years where we focused on making progress on hardware and getting plenty of launch experience under our belt. So our mission at Astra is to improve life on Earth from space, to find ways to create a healthier and more connected planet. From powering more efficient and affordable agriculture to helping the forestry industry fine-tune their sustainable practices, the implications of sending satellites to space are exponential for our global economy and populations. As we've mentioned before, Astra is headquartered in Alameda, California, which is just across the bay from San Francisco. We have a 250,000 square foot factory on the grounds of the former Naval Air Station in Alameda, and we test our rocket engines just across the street in indoor test cells that were once used by the US Navy to perform jet engine testing. We have conducted 2 suborbital test launches so far, and today's launch of LV-6 is our 3rd orbital launch attempt, with hopefully many more missions to come. And if you're interested in staying in the loop on our work and announcements, you can follow us on Twitter. Our handle is @Astra.
Cool. So you must have got your answer, Tommy.
To this being the first of many launches to come for Astra, not just from Kodiak, but from elsewhere as well. Again, if you have questions about anything you are seeing, throw them in the chat, tag us with that NASA Spaceflight, and we're going to keep going through those throughout the countdown. Again, if you're just joining us, we're in a hold at T-minus 20 minutes. Team's continuing to work through the countdown. We have a fair bit of time in today's window, so we'll just keep an eye on when that clock is released for a new T0 time. But in the meantime, propellant load still underway. You can see the vehicle getting nice and frosty as the super cold liquid oxygen flows in and the kerosene on the bottom of that. And yeah, we're going to continue to provide updates as the countdown proceeds.
Good. So yes, you should have got your answer, Tommy. As I was saying that engines are made in that level where you separate them and you basically divide by 2 and get an average height, and you design your engines to perform the best at that level. So as you just heard that these engines are tested at a jet engine test facility for US Space Force or not, I don't remember, but yeah, you heard it actually the engines are tested at the jet engines facility, and jet engines kind of, you can say that they operate at at that altitude only, where you kind of can expect the average height for this first stage booster. So yes, that makes sense also, and what they should be doing. And it is not complete vacuum, but yeah, second stage may be tested in the complete vacuum, but the first stage is still tested in the normal pressure temperature. How tall is this rocket? Is this like Falcon 1? It is shorter than Falcon 1. The Falcon 1, if I'm not wrong, was around 69 feet. This is around 43 feet. And obviously the payload capacity is also according to that. It can take around 25 kilograms to space, right? If this is successful launch, what would be the implications for the company going forward? Well, if this is a successful launch, first of all, they would know how to get into the orbit. That is the most important thing you want to know, first of all. Okay, when they know that, then they can do some changes in their rocket to make it carry some more payload. Right now, maximum it can carry is 25. So they, like from rocket 2.0, when they went from rocket 2.0 to rocket 3.0, they increased the diameter, hence increasing the payload capacity. So similar to that, you can kind of say they can optimize the rocket. Jet engines are not the same, Tommy. Yes, they are not the same, but they operate at a certain altitude, which could be the average altitude for the first stage booster. That's what I'm trying to say. Yeah, I said that when the separation happens at that altitude, separation usually happens at around kind of I don't know about this rocket, but 50 to 60, so 25 kilometers or so. So you can kind of expect that. Uh, I'm saying that they are where the jet engines mostly operate. The average height for the first stage will also be that, so that they can test it optimally. Okay. What are the engines called on this rocket? The engines are the Delphine's engines at the first stage, and the second stage is there is a I'll tell you what's the name of the second stage. There's a different. Meantime, what else do we? What are the aerospike engines? No, no, they are not aerospike engines. How many engines are there on the first stage? First stage has 5 engines running on the electric pump fed cycle. So that is one thing. Okay, now name second stage. Ether engine or ether engine, whatever you want. The first stage is Delphine engine, 5 of them, and the second stage is the ether engine,
And again, as I
one
say, let's listen
of
into
them.
the countdown net. The countdown net gets nice and quiet. We will keep listening into that and checking in on how the teams are proceeding through the countdown. In the meantime, we'll keep taking some questions here. And about those launch teams, we have a question about what's the difference between a launch conductor and a launch director?
Yes, so our launch director is the final launch authority who's responsible for the safety of overall launch operations, while the launch conductor is the person who oversees and directs launch vehicle operations. It's the one who's following the countdown manual, who can call hold, recycle, or abort as required. And as we are in this hold, that is one of the responsibilities of the launch conductor. We are in this hold as the team updates their software configurations on the vehicle.
Gotcha. A couple questions about the operations around today's launch. We have one asking, how big is the exclusion zone around this rocket, and does anyone have to vacate the area to launch from Kodiak today?
Yes, we do want to make sure that safe operations of both people and property are followed. So don't know the precise dimensions of that exclusion zone, but we are working with the Coast Guard and the FAA to make sure we're clearing the airspace and we're clearing the ocean as well, and making sure that the beaches are also clear of anyone who may be a little too close to our rocket launch.
And keeping on the content or on the topic of launching from Alaska, we have a question asking, isn't that less efficient than launching from, say, Florida or someplace closer to the equator?
Well, that entirely depends on where you want to go. So our payload today, our test payload, which will not be deployed, is going to a high inclination, and Kodiak is great for reaching those types of orbital inclinations as well as polar orbits. So different launch sites can get you different access to different portions of space, and so we really like launching from Kodiak when we need to go to those polar orbits.
And correct me if I'm wrong, I think it would actually hurt you if you were trying to launch to a polar orbit from Florida, because you actually have to get rid of a lot of that extra velocity you get from being closer to the equator.
That's right.
Exactly.
So those low inclination missions, which launch closer to the equator, they take advantage of that. But if you're trying to launch into a polar orbit, it actually hurts you, which is why launching from up north in Alaska works so well. And also, I believe there's another benefit, at least for these early test flights, for being at a launch range that's not very busy and more remote than some of the more busier or more traditional launch complexes.
Right, definitely. One of the reasons why we have enjoyed working at PSCA, our Pacific Spaceport Complex in Kodiak, is because they've been really helpful in working with us on getting the availability that we need and making sure that we can hit our launch schedules and our targets.
We're seeing a lot of really cool venting from the pad there. You can also listen into the pad mics and hear that. It's super cool to hear. About that ground equipment though, people asking, does that launch base also fit into the shipping container, not just the rocket? I believe it's all the equipment ships up that way, right?
Right. Everything that you see here fits in standard shipping equipment. So that rocket itself fits in a 45-foot shipping container, and everything else that you see, aside from the concrete ground, does go over boats and trucks to our launch site.
So kind of it is a mobile launch pad.
Also, we're getting a really good view here of the top of this rocket, that payload fairing, and we have a question about that coming from chat. It's got a bit of a unique shape. It looks like it might even split into more than two pieces, or is it? If that's not the case, what is the deal with that cool fairing shape?
Yeah, we will hopefully see the fairing split. It is broken down the middle into two halves, and so one of the things we were really hoping with today's flight is that we see that beautiful fairing separation of the two halves coming apart, so we can complete our mission. And if we were to deploy a payload, that's when we would deploy a payload after that fairing has separated from the vehicle. But again, it is a test payload today that will not be deployed.
And a bit of a unique aspect to the Astra Rocket 3, I believe that fairing separates also not just to expose the payload, but to expose the upper stage. That fairing actually separates prior to the two stages separating, right?
Mm-hmm. That's correct.
So as we continue to move towards our eventual launch time, again, teams are currently holding, continuing to, with those pre-launch preparations. But once we can get that clock counting again, as long as those winds cooperate as well, we'll hopefully be able to see that really cool stage separation. It's very cool to see. In the meantime, if there is a hold later in the countdown, I know we did not get into terminal count yet, so we haven't had this issue yet. But once we get past that terminal count point, about 15 minutes into launch, how fast can that rocket recycle and make another launch attempt?
Yes, absolutely. So with this type of hold, we would pick up the count right where we left off. If we are within that 15-minute terminal count period, we would recycle the launch attempt from the top of that 15-minute mark.
Cool. The good info.
For this particular version of the rocket, a question in chat about what the maximum weight for a payload on Rocket 3.3 is right now.
Right. So again, that depends on where we're launching from and where the payload wants to go. Our capacity does vary because we are a small rocket. There's some variance in where we can, how much payload we can get to different orbital destinations.
So basically, I'll answer that question for you.
We talked a little bit earlier about Astra working to also scale up to slightly bigger rockets, hit those different payload mass goals and things like that. Astra's got a lot of long-term goals, that big one being that daily launch cadence, which is so cool just to think about that being enabled. Where do you see Astra in the next 10 years or so?
Absolutely. I think daily space delivery is something that we've said we are passionate about and we are heading towards, and so we're making strides towards that goal. And it'll also be really interesting to see where the whole industry is in 10 years from now. Thinking back 10 years ago, that was near the end of the space shuttle program, and many of these commercial launches were just coming on the horizon. It's amazing to see the progress that I don't think could have really been imagined at that point 10 years ago. So who knows where we're going to be 10 years from now, but I hope it means a lot of rockets.
For the NASA spaceflight editors watching this stream, you hear that? That was a shuttle reference. We got one in for this stream, okay? We're going to continue checking in for activity on the countdown net and listening into those pad mics as we wait for teams to continue working towards clearing this hold.
Okay. So, yes, let me just first answer that question for you. That it varies, the payload capacity basically varies where it wants. Let me give you an example and try to explain. So if it is launching from close to the equator, so it is actually having some velocity of the Earth rotation. So, okay. And let's say it just wants to go into an equatorial orbit. So what it will do, it will just launch up and then go into the direction where Earth is rotating. So because of that, it gets the initial extra kick from the Earth itself. Earth itself, because Earth is rotating in a certain direction, and if the rocket also goes into that direction, so therefore it takes that velocity with it, and the final velocity which it has to achieve to get to the orbit decreases, and hence you can kind of improve the payload capacity there. So in most of the cases, the LEO capacity, which is a equatorial capacity, that is greater than the other capacity, wherever other inclination it wants to go. And talking about the polar one, so polar has those issues with them, because you don't want to go in the equatorial direction, which means you don't want to have an horizontal velocity, but you will get some horizontal velocity since you are launching from Earth and Earth is rotating. So what you do you try to minimize that horizontal velocity. How do you do that? You do that by launching it away from the equator. Okay, so what will happen, since a launch pad, when it is near to the equator, it will have the maximum velocity, okay, of the earth's rotation, because of the earth's rotation. When it is away from the equator, the velocity will decrease, and kind of, you can say, the polar region, it is almost kind of near to the zero velocity. I won't say exactly, but yeah, the most optimal launch site would be the poles, if you want to launch from there, okay, for the polar region. And yeah, so that is the case. So launch site, since now this is launching from the Kodiak Island in Alaska, which is kind of in the northern region. It's not in near the equatorial region. So therefore, the velocity required is decreased. Okay, velocity required is decreased to, because you have to cancel that horizontal velocity which is going, the Earth is giving to you, or going into a polar orbit. So that is decreased, first advantage. Second one is, now since you are going to the polar orbit, the velocities kind of tend to increase. I mean, the required velocity tend to increase to get to the orbit, because you need to cancel out the horizontal velocity, and hence the payload capacity decreases. So this is a trend which rockets follow. When it goes to equatorial orbit, it tends to carry more payload, and when it goes to a polar orbit, it tends to carry low payload, because of this reason, because it has to cancel that horizontal velocity. And first of all, it has to cancel that horizontal velocity, and the second of all, that the earth does not provide any initial kick to the rocket. Initially, it actually holds the rocket. So yeah. Wow. Do you hear those sounds? It's cool. Will the extra rocket be reusable? Nope, it won't be reusable. It does not make sense for it to be reusable, indeed, because this is a small rocket, first of all, and it has literally 25 kilograms of payload capacity right now. And you don't want to decrease the payload capacity, because any type of reusability measures you will try to incorporate it, the payload capacity, there will be some kind of payload penalty. So for small set rockets, the reusability does not make sense most of the time, but right now they don't have any plans for this rocket, at least. Maybe they develop some other rocket in future, they will go on for some reusability. And yes, Jeremy, you are right. The stage one is bigger to push the rocket past that 1,500,000 feet quickly above most of the Earth's air. Yes, this is bigger because it consumes more fuel, right? As he said, that it has to, first of all, it has to, counter those drag forces, the gravity losses, the gravity turn losses. All those things are there, and it has to, fight all of them, and it has to do it very quickly, so that it is out of that atmospheric region, and hence it consumes more fuel at that time, so to enable it to, fight all these forces. And since it consumes more fuel, therefore more fuel needs to be loaded, and hence the first stage is kind of, you can say, is bigger for all of the rockets. There any stage in which the first stage was smaller and this basically second stage was bigger? I don't think so.
If you are just joining us, we're here at Alameda's headquarters in California for live coverage of the launch vehicle 0006 launch. My name is Thomas Burkhardt. I'm a news director at nasaspaceflight.com. And joining me is Carolina Grossman, Director of Product Management at Astra. We are still in a hold right now. Do you have any updates for us?
No new updates since the last time we heard from the team. They are loading software configurations, and we are still holding at T-minus 20 minutes.
We have gone through a very large part of the countdown to get to this 20-minute mark. Teams continue to work through some issues. But in the meantime, let's talk a little bit about the launch that preceded this one. We want to show a highlight video of Rocket 3.2's trip to space. And this is what we're going to be hoping to see later today. Hopefully, there was that water deluge that we said was very dramatic, but it looks very cool.
Wow.
And there's only some minor changes from this Rocket 3.2 launch to the one we're hoping to see today. So should look fairly similar if all goes well.
Kind
That's
of
right.
has
We
high
are hoping that
TWR
we have
also.
resolved the issues that caused us to fall just shy of orbit, and we've also made some changes to increase our payload capacity on this vehicle.
This is a nice small rocket, so you'll notice that those early clips, it really likes to leap off the pad. I'm really looking forward to that. And then these stunning onboard views of stage separation and the upper stage ignition, hoping to get that live today as well.
Absolutely. It was an amazing moment here for the team at Astra to see that engine light and that beautiful stage separation is what you're seeing now, the fairing falling away. And it was a very, very exciting and happy day for us at Astra.
Those were the footage which you
Okay,
could
in the
see.
meantime, we're going to keep taking some questions from chat, and I've got one here asking about the lightning protection system out there in Kodiak. I see I've got two phone poles with lightning rods on them. Is that your lightning protection system?
Yeah, I was going to say, you took the answer, just like Jeopardy. That is our lightning protection system.
So it is not the 4 towers that we may have seen out in Cape Canaveral sometimes, but still a lightning protection system out there for Rocket 3.3. Keep it going with some questions here. People asking, is Astra thinking about anything beyond low Earth orbit or Earth orbit?
Well, our focus and our mission is to improve life on Earth from space, so we are keeping focused on Earth orbit.
Another question from chat asking, how long does it take to manufacture one of Astra's rockets?
Right, well, we are actually ramping up for monthly production and hoping to complete 3 launches this year. So that is where we're at the moment, and hoping to continue making that faster and faster as we take steps to daily space delivery.
Cool.
And can you talk a little bit about how Astra is working towards achieving not just the high launch cadence, but the low cost building price for these rockets?
Yeah, absolutely. It's certainly one of the unique aspects of our launch system is that we focus on proven and cost-efficient parts as much as we possibly can. As we've said earlier in the broadcast, many of the components that you see on the rocket come into our factory as raw sheet metal, and we have our in-house machine shop team and our production team that turns it into flight hardware. And so we try and stay away from costly and labor-intensive materials like carbon fiber and 3D printing. We do use them sparingly, but they tend to be expensive, and more importantly, they are very difficult to build at scale. So we're focused on making a production line that can build and test rockets at an unprecedented pace. So we need to aim for simplicity in that design, and as we like to say at Astra, simple scales.
Exciting
Again, if you are
times
just
ahead.
joining us, we're in a hold at T-minus 20 minutes as launch teams continue to work. We'll continue to provide updates as they move towards clearing that hold and moving back towards a T0.
Okay, so what I was saying, is this an aerospike engine? Nope. First stage has to break there, does not. Okay, so let's take some more questions now. Is this an aerospike engine? No, it's not an aerospike engine. It's a normal engine, a electric pump fed on the first stage and a pressure fed on the second stage. So Dev Pratim says, I just calculated Rocket 3 will gain around 212 meters per second if they launch to Leo from the equator as compared to Kodiak. Wow, that is good. 212 meter per second. Okay, this is the velocity you calculated. How much payload would be the thing? That if you know, if you can do some maths on that, that would be great. Because you know the velocity now. So how much payload for that velocity? That would be great if we know that. Carl says Electron is pursuing reusability. Exactly, it is pursuing reusability, but it has some mass to play with right now. Is kind of has 200 kilograms to unsynchronous orbit. It has that payload capacity, so it does have some mass to play with. But this one, 25 or to maximum 150, it won't be having some those things to play with. So and the second factor why they don't pursue with reusability is the economics factor, that by doing by basically modifying the rocket and pursuing reusability for a rocket, the economics will not match up. You can rather throw a rocket, you will be better off throwing a rocket rather than recovering it. That's how the economics kind of work, because you have to first of all make some changes in the rocket, then you should have the recovery team, uh, and then the recovery cost, then refurbishing cost, all those things add up, and they need that break even analysis, like when would be that factor, and how many reusable how many rockets we would have recovered, since how many rockets we would have recovered when we will start gaining the profit basically. And I don't think so that would match up for a very small rocket. So yes. What is the locations or the latitudes will be able to see the rocket with binoculars? If you live near this Kodiak Island, you should be able to see this, because this is going to a polar orbit. So is not even going to equatorial orbit. So I'd suspect if you just live in that polar region near the Alaska, you may be able to see it. You can just Google the the exact launch site of this thing, and maybe just look at that direction at the time of right now. Can't say anything that. Okay. Polar orbit satellites have the advantage to circle the whole Earth in about 28 days and they cover the whole Earth. Yes, because I don't know about the days how much. I don't think so. It will take just 28 days to cover the whole Earth. That would depend on the swath area which is happening, if you are talking about the Earth observation satellite. But okay, let's say it is 28 days. But yes, the polar orbits have those advantage, because the Earth rotates from below, and the satellite is also rotating but in 90-degree, and the Earth is also rotating but in a 90-degree angle. The orbital basically the inclination is 90 degrees, so therefore it tends to cover all of the Earth, for if it is orbiting at for a certain period. How much does it weigh? Without fuel, we don't know. That's a kind of a secretive company. So right now we don't know, but we do know the length of this. It is around 43 feet. It is going to low orbit. It's a low orbit. Tommy, is there a fire extinguisher at the base of the rocket? Uh, I don't see those things right now. The lighting is also not great, so may not be able to tell it. But let's see if it is a thing. But no, on the launch pad, most of the time there are those water hoses which are
Okay, this
installed.
is Astra LC
So
on countdown. We are at step 112. We will be doing software load, then setting ourselves a new T0 time. Tango, have you refreshed and are you ready for config loads?
Yes.
Tango, at this time, please go into machine pump battery 2, manage pump battery charge. Toggle stop charging batteries.
Copy that. Stopped.
In AV1, manage power systems. Please toggle off guidance power system authority.
Off.
In AV1, manage polling, toggle do only ground.
Only ground.
And Tango, let me know when you're ready to load new configs.
Tango's always ready.
Engine Alpha 125 Victor 7.
Alpha 125 Victor 7. Loading. Loaded.
Bravo 126 Victor 7.
Bravo 126 Victor 7. Loading.
thing to hear control callouts. This is how a software is loaded inside a rocket. Kind of, you can say that. Cool. How long this hold right now we don't know. Maybe not. We are not very far away from lifting the hold because we could hear the mission control was loading the software configs to the rocket, so we might be able to see they pick up the launch countdown in just few minutes or so. Is this mission heading to ISS? Nope. Okay. It was very unfortunate actually when the rocket 3.0 launched, 3.2 launched, because it was just did achieve every other task, but because of the fuel mixture ratio, it was not able to gain that 500 meter per second of velocity, which was kind of a bummer. But let's hope they have improved. Obviously, they would have tested it now, the fuel mixture ratio, and improved on that. Hi, Louis Smith. After so long, you are back, right? How are you? Okay. Could you please introduce yourself? I am again saying I would do that. Right now, you just um, kind of say that I'm a very big space enthusiast. I like to read about space and rocket science. Whatever knowledge I have, I tend to share with you and kind of improve the awareness on space, because space is a sector which unites humanity as well as a booming sector, and a thing. Space is one, frontier where it's like a whole new biome where so many things are needed to be done, and I'm very excited for that, and I want people to also get excited. So kind of you can. I'm well, thank you. Been working a lot. Hope your exam went well. Yes, they did went well, but still ongoing. This kind of, what should I say? Was unfortunate, but they are still ongoing, and let's see. I'll still be streaming, but you may not have those videos incoming right now, but I will still be streaming the launches. Do you work for Astra? No, no, no. I don't work for Astra right now. So, yep, that answers your. I just know some kind of, you can say, whatever knowledge I have, whatever I have gained from reading research papers, books, all those things. I try to share them.
Tango, are you ready to try to load engine Charlie?
I am.
Charlie 127 Victor 8.
Dolphin Charlie 127 Victor 8 loading.
Thank you so much, Dev Pratim, for your wishes. Yes, it's kind of sucks right now. We all are very, my classmates and all are very frustrated with this delay, because um, there is some delay which is causing the exams to be postponed a lot. That's why sometimes it's still not over. The exams are still not over yet. In 2 months. But yeah, that is how things are going. Uh, how long will this test flight take? From the liftoff to the, can say, the second engine cutoff, it is around 8 minutes and 30 seconds. Is the time for the flight. I am currently having the online exam, but problem with the online, they are actually facing some technical difficulty with the online. That's why we are having some. That's why they are getting again postponed, and we don't know when they will be again. We do know the dates, but we don't know whether that would be the perfect date, because technical difficulty again can happen. Is it delayed the hold? Yes, they are delayed. Right now the vehicle is on hold. They are loading
Tango
the.
engine Delta.
Okay.
Delta
128 Victor 7.
128 Victor 7 loading.
Okay, so yes, it is on hold right now. They are loading the software configs.
Loaded.
Engine Echo 129 Victor 7.
129 Victor 7 loading.
And guys, uh, if you haven't liked the stream till now, it would be great if you can do that. We are right now just at 83 likes, 400 people watching. Can we make it to 200 likes? If you haven't liked it already, it would be great if you like it. I mean, your choice obviously, but if you like what I do and like my knowledge and stuff, you can do that. His computer has googly eyes. Are those googly eyes, or is that those I guess that is a custom made. I mean, he had done something to those computers, because all other computers does not have those things. So yes, you can say that. Did you see that all the renders of Neutron released by the Rocket Lab were a joke? Joke, yes. I heard that news, but well. Let's see. Because Rocket Lab is a company which tends to do some innovative PR, which we all know from their mission names and patches. So I won't be surprised if those renders were not real. Those renders were like, the expectation which we had, but uh, I think they are exceeding our expectations. Have to wait and see. How long does it take to make this rocket, and how much? So the cost per launch is very low. The cost per launch for this rocket is around $2.5 million. That's it. $2.5 million. So you can, and this is going to the orbit, and it is not achieving.
Okay.
It's not a
Tango, I'd
sounding
like you to
rocket.
try loading ether sequence 101 Victor 10.
Ether controller config 101 Victor 10 loading.
So right now they're loading the software configs onto the second stage. Thanks for the coverage. Thank you so much, Adam, for you to come here. And if you guys want to support me in what I do, and you want to, you want me to keep on doing this, you can do that by becoming a member of this channel, clicking on that join button, or becoming a Patreon. That would be very much appreciated. Or for a one-time funding, super chat is always enabled. That really helps the channel to stay alive. Must say that, because most of
All
the
right.
revenue
And Tango, I'd like you to
is
load
kind of
guidance
earned from this thing.
configuration 5 Victor 127.
Guidance config 5 Victor 127 loading. Loaded.
ये भाई हिंदी आती है बट बोलते नहीं है, because have international audience to cater to that, right? uh, the whole video is yes. I won't say, see, those renders could be different, but may not be fully, what should I say, different. I won't be like we are saying, seeing some the side booster attached rocket. I don't think so that would happen. Let's see. You can also, guys, join our Discord server. We do a lot of talking on that. The link is in the chat only. You can click on that, join our Discord server. In what we discuss about space flight events and everything, memes, KSP, the SFS also. So if you want to have some fun, you can do that. Join our Discord. Is our in the chat box, right? And you can subscribe for daily launches. I mean, not the daily launches, but the launch coverage streams with the in you if you have known me for a while, you know what I do.
All right. Tango, with guidance config loaded, can you please give me a GNC setup, please? Calling out when complete.
Copy that. Setting up GNC.
Guidance and navigation control system. The software is being loaded on to that. She said that we had a good opportunity to launch at the starting of the window when the wind is not that much of a factor. And since now we have been on a hold for so long, let's see how the wind will, work, because still it's not a very, it does not have an instantaneous launch window. The launch window kind of extend till hours. So let's see how the things. Maybe he's joking. We don't know that. Okay. Entire rocket will look nothing like that. Okay. Maybe they are, let's see. Let's see what happens. Maybe. Maybe if it is like a bigger rocket or what. I don't know. Let's see. 40 minutes later and still holding. Okay. Okay. In the meantime, we can discuss about the events which have happened past week. What have happened? Okay. Is there anything happened as such? Yes, the Tesla bot has been announced. Is one significant event. Other than that, we all know what Blue Origin has, but I don't. We are moving closing. We are moving a little bit closer for the Starship Orbital
And if
Flight
you're
2.
joining us, we are still in a T-minus 20-minute hold. However, teams are working through it.
Thank you, Tango. And an AV1 managed polling, please set us back to both ground and guidance.
And we're getting very close to a
Both
new
ground and
T0,
guidance.
so stand by. We should have a new launch time for you shortly as teams continue to resolve just some quick issues before we release the hold and get back to counting down.
Weather's still looking good, so we hope to have that new T0 very soon.
Okay, that is a great news. Weather seems good, right? Let me see if there is any update. We are missing update you.
This is Astra LC on countdown. We are picking the count back up at this time. We are on step 119, moving into Delphin pump spins. Tango, can you please activate machine AV1 power ESC ace dry spin?
It is active.
Tango, please toggle on power ESCs.
Power ESCs toggled.
And as you can see, we're now counting down. We've recycled the clock just a little bit now, 21 minutes and counting. That gives us a T0 of 45 minutes past the hour, 2:45 p.m. Pacific time, our new target launch time. Carolina, how are things looking for the launch attempt today?
Well, as you've heard, we were in a hold troubleshooting some software configuration issues, but that seems to be resolved. We're back into the count. The team is now completing pump spins for the first stage engines, and will be shortly moving into the final preparations of our pre-flight, including that water deluge test.
This
Gotcha.
we
Now
are
that the
picking up
clock
the
has
countdown.
resumed,
That's
we're going to take
great.
a couple more questions before we get into that terminal count section. We do have a question in chat about will there be any onboard views from the rocket? I can field that one. We are hoping to have some onboard views, but of course that is dependent on how reliable and steady that telemetry connection is. Obviously there is more higher priority data, so we can't guarantee that connection will stay rock stable, but if it is, we promise that we will be showing it best we can. You can see some of the views on there now. That's actually the second stage forward-looking camera up into the payload fairing, one of our onboard views, and we'll be showing those best we can once liftoff has occurred. And there is the other stage 2 camera looking down. You can actually see just the black outline of that Aether engine, which we will hopefully see igniting in space before too long today.
Fingers crossed.
Some other questions. We have one from chat asking, what function are those various umbilicals providing between the launcher and the rocket itself?
Yes, so those umbilicals will help pump fuel, our propellants on board the rocket, as well as provide communication, and that's how our team here in Launch Control in Alameda communicates with the vehicle. And those umbilicals will disconnect as the rocket takes off.
And it sounds like we are getting very close to that water deluge test. That'll be a nice visual indicator that the countdown is proceeding.
Let's see that.
T-minus 19 minutes and counting to the launch. Again, a new T0 of 2:45 p.m. Pacific time.
So yes, the TW is kind of a bullet. The TWR for this rocket is high, and when I guess it also performs a Baumgartner maneuver. Let's see. It would be a nice little touch during the liftoff.
And you just heard we had another quick weather brief thrown in there, and that the wind profiles look good right now. So that's another good sign as we count down towards launch.
That is great.
We have another question here in chat talking about the Apollo fusion, which is now involved with Astra. Carolina, what can you tell us about that?
Yes, absolutely. We are very excited to have the Apollo Fusion team and technology as part of Astra. We completed
We'll toggle off on my call.
that acquisition in July.
And really quick, I'm going to cut off that answer because we are coming up on that water deluge test.
Some tight venting here.
Off.
Hey. This is cool.
There we go.
A small test to ensure.
Tango in the water system machine. Toggle pump full to false.
So Carolina, did that look good to you?
That looks like a successful deluge test.
So hopefully the next time we see that will be at ignition.
Just a few seconds before. Yes.
Perfect. So to get back to the question that the water deluge test so rudely interrupted, can you tell us a little bit about Apollo Fusion and how they relate to Astra?
Yes, absolutely. So we chose to work with Apollo Fusion because they have a system that is cost-effective and reliable at scale, which is very aligned with what we are trying to do with our rockets at Astra. Apollo measures their design cycles in months, not years, and are focusing on solutions that are easy to manufacture and assemble. And they don't see their job as done when they have something that initially works, but they continue to optimize for manufacturability and scalability, just like we do with our rockets at Astra. And earlier this week, they had some very exciting news that Apollo Fusion's thruster ignited in orbit, which is a very important milestone in our journey to provide rapid, low-cost access to space. So shout out to the Apollo Fusion team for that milestone, and we at Astra are very excited to continue our partnership.
Again, we're at T-minus 16 minutes and counting, starting to get into the business end of this countdown. One of the next big milestones is going to be the entering of the terminal count at T-minus 15 minutes, so we're just under a minute away from that. We still have some more questions. We'll get through a couple more of these, but of course, as usual, once we get into that business end of the countdown, we're going to leave it up to the countdown net to do most of the talking here. But before we get to that, we're talking about Apollo Fusion, Astra acquiring them, and we just have a question in chat that they're not super familiar with Astra as a company. Don't blame them. The first live broadcast of their launch. Are you guys headed for an IPO? I believe I might know the answer to that.
Yes, we did also IPO in July. It was a very exciting month for us, so we are a public company.
Which is very, very cool, and an increasingly prevalent part of the space community that's pretty new, but it's very cool. And again, at T-minus 15 minutes, about to enter terminal count. And there is the 15-minute mark, Rocket 3.3 now in its terminal count for the launch of LV0006.
This is in the terminal count, which means that if there is any hold now, they would have to recycle it back to minus 15 minutes, and we are at the terminal count, which means
So
everything is looking good right
will come
now.
up at just about 10 minutes, a little over 10 minutes before launch, when the teams will give their final go and no-go for tank pressurization and launch. That's the next really big milestone we're going to be waiting for.
Okay. So,
Self-check is passed.
Copy that. Thank you. We have confirmed Astra FTS is still enabled on the vehicle. Tango, at this time in Fuel 4 operate, can you toggle full? Full. Fast.
Fast.
So now that we have
Tango,
entered
please
terminal
inspect
count,
the launch machine.
I don't want to talk over the countdown then. There we go. Now that we have entered terminal count and are about just under 15 minutes from liftoff, how are things looking today, Carolina?
We are looking good. We are about to set a new UTC T0.
Minutes 4-5.
And that is that 45 minutes past the hour.
4-5.
Seconds 0-0.
Second 0.
Please
So
save.
we have
Saving.
confirmed that the weather is go for launch. We have no issues with boats. The range has given us the go-ahead so far. We'll confirm that later on in the countdown.
And as we get closer to launch, just again, for those of you just joining, let's go over the details of today's mission, Carolina.
Absolutely. So LV6 is Astra's third orbital launch attempt and our first commercial orbital launch with the United States Space Force. It's for the Space Test Program, and by commercial orbital launch, we mean that this is a launch conducted under an FAA commercial launch license. Our goal with this flight today is to successfully reach orbit and do so with a test payload which we will not release. This orbital demonstration launch allows our team to verify numerous upgrades to our launch system since Rocket 3.2 was launched in December. Today's launch is an important milestone in our work at Astra. What we learned today will get us closer to launching our next payload. And before we get further into the count, I'd like to give a big thank you to the entire Astra team and their families watching with us today. We couldn't do this without your support. Thank you all so much. After December's launch, we've been excited to get back to the pad with LV6. As a reminder, in our previous launch, Rocket 3.2 successfully passed the Kármán line, the 100-kilometer altitude that's commonly used as the demarcation of space. While the rocket narrowly missed making it into orbit, we were ecstatic with those results. Rocket 3.2 shut down 12 to 15 seconds too soon after depleting its fuel at a peak altitude of 390 kilometers and 7.2 kilometers per second, which is just half a kilometer per second short of orbital velocity. It's so close. And since then, we've been fine-tuning that mixture ratio between our kerosene fuel and liquid oxygen to propel us further. I also want to take a moment to recognize the efforts of Astra's Red Team. The rocket is controlled from our headquarters here in Alameda, California, and we send a team of 6 Astra personnel, known as the Red Team, to Kodiak for the launch. Because our rocket and support systems were designed with simplicity in mind, we only need a small and nimble team on site for the launch. It also helps us limit travel, which is a key consideration as the COVID-19 pandemic continues. All 6 members of our Red Team are taking regular COVID-19 tests to protect the health and safety of everyone involved in this mission. We hope you and your loved ones are staying safe out there as well.
Absolutely, Carolina. We are coming up at T-minus 10 minutes, 45 seconds and counting. We are rapidly approaching the final go, no-go pull for tank pressurization and launch. So let's listen into the countdown net and see if we're good to go.
Active.
Toggle LOX topping.
LOX topping.
Team, this is the poll for tank pressurization and launch today. After this point, any system issue must be called as a 3-word hold. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
FTS is go.
Delphin.
Delphin is go.
Ether.
Ether is go.
Odin. Inco.
Inco is go.
Ace.
Ace is go.
Launcher.
Launcher is go.
Orbit.
Orbit is go.
Booster.
Booster is go.
GNC.
GNC is go.
FAO.
FAO is go.
CDH.
Go.
Tango.
Go.
Safety.
Safety is go.
LD.
LD is go.
LC is go as well. Tango in AV1 manage. Polling toggle do only ground.
Only ground.
Delphin, please provide flight engine sequences for us for today.
Engine Alpha sequence 785 Victor 9.
Alpha 785 Victor 9 slot 0 loading. Loaded.
Engine Bravo 786 Victor 5.
Bravo 786 Victor 5 slot 0 loading.
And we
As
have
you just heard, teams have pulled go for the launch of Launch Vehicle 0006, Astra's third orbital launch attempt, just under 9 minutes from now. We're now in the meat of the countdown and getting close to the final countdown towards liftoff.
wow.
And a little bit about our goals for today. We've talked about achieving orbit, but that is very difficult, and so for this reason, we're being realistic with our expectations. Today is our third attempt to reach orbit and our first test with a sample payload provided by the Space Force to simulate mass. And right now, the team is loading the final flight software onto the vehicle and going through those final preparations for launch.
So now that we're just about 8 minutes away from liftoff and the teams are counting down towards that T0 of 2:45 p.m. Pacific time, as we enter those final minutes of the countdown, I'm now going to hand it off to Carolina and the countdown net for commentary of Astra's third orbital launch attempt. Carolina, take it away.
Absolutely. We'll start by telling you about the major flight milestones that we'll see on this flight. They will be displayed on your screen for you to follow along. At T-minus 3 seconds, the 5 first stage engines will light. If the engine data looks good, the hold down release mechanisms will let go at T0 and the rocket will begin its trip to space. At T plus 25 seconds, we will clear the range and fly over the Pacific Ocean. LV6 will reach max Q, which is the period of maximum aerodynamic pressure on the vehicle, at T plus 1 minute. Main engine cutoff, or MECO, which signals the end of the first stage burn, will occur at T plus 2 minutes 18 seconds. This is followed quickly by fairing separation and stage separation. At this point, the rocket will be in space, just over 100 kilometers above the surface of the Earth. But then there's more if all goes well. After stage separation, upper stage ignition happens at T plus 2 minutes and 32 seconds, and then the upper stage burns for about 6 minutes until SECO, or second engine cutoff, at T plus 8 minutes and 48 seconds. Then, since we're not releasing an actual payload, the vehicle's systems will simulate a signal for payload deployment. If we make it this far, we will have made it to orbit and would consider this flight to be successful.
Hey guys, let's keep our hopes high and let's just be optimistic and
Now everything
I
continues
believe
to be
them.
on track,
Let's
just
see
over
what
6
happens.
minutes away from launch.
We are 6 minutes and 20 seconds away from the launch. Everything is looking great. I am so much excited. I can't tell you. I'm just looking forward to the launch.
Rise to launch. Thank you, sir.
Okay. This
As you just heard,
Okay.
we've just been given the go-ahead for launch from the range.
So guys, where are you looking? I mean, Where are you watching this stream from? Just type in the chat and we'll see whether the world is watching or the country is watching. Okay. So we are T minus 5 minutes, 46 seconds. Everything is go. I'm so much excited. Yes, I am again telling you it has a great TWR. So it would just kick off from the pad. So do not blink and you would see a beautiful, beautiful show put up by this rocket. And it would be totally majestic. And let's just see it. Scotland, Dallas, England, Canada, Paris. Okay, wow. Spain, Florida. Hi, Ontario,
And
Indiana,
now in the
Australia.
final almost 5 minutes to T0,
Hey,
we expect
Wales.
that the vehicle will transition to its internal control at T minus 60 seconds, and we'll be continue to listen to the countdown in these final minutes before liftoff.
Tango at this time, please enable launch.
Call Virginia, Texas, Canada,
Launch
Spain,
enabled.
Delaware. So we are having people from all over the world watching this, and you can see now the people
That's a
are
great
getting
shot of the teams
excited.
here at Alameda, watching from next to Mission Control, just behind us.
You should be
Again,
hearing
just under
those
5 minutes away from T0.
cheering and everything. So guys, it is finally happening. T minus 4 minutes and 30 seconds. It's like are you using the KSP today? Unfortunately no, because I guess we won't be needing that for this launch. Let's see. I guess we would have a proper coverage here. And how tall is the rocket? Yes, it is at 43 feet rocket. So guys, T minus 4 minutes. Okay, I am very excited right now. I just can't control myself. We should be seeing that beautiful water sprayed onto the pad first of all, and then the engine
4
ignition,
minutes.
which itself would be a great show.
RCO LC on countdown.
RCO go.
Please verify range is recording telemetry.
Range is recording.
Copy, thank you.
So T minus 3 minutes and 30 seconds. Thank you so much all for joining in. Will you be covering the SpaceX
Control
tomorrow?
room,
Well,
if you require RF
I'll see
data
that.
in flight, be
Not
prepared to switch
commentating
over
on
your
that, but
fauna
yes,
pages.
I'll try my best to do that. Has it got a camera on board? Yes, it does have. It does have the camera to capture those beautiful,
FSO,
beautiful
prepare to
images.
issue option command at T plus 164, calling out at event.
FSO copies.
3 minutes.
Under 3 minutes to go to the launch of Astra LV 0006.
Okay. It is happening. Finally. T minus
Any
2 minutes.
three-word hold called from here on out is an immediate abort, regardless of source.
Thanks for your information, and let's hope that does not happen. T minus 2 minutes and 30 seconds in counting. Whoa, we are at the terminal count, guys. This is the time. This is the day which you should remember when the Astra is
FTS.
starting
Please
their
send
commercial
master
launches.
enable and watchdog on AFTU.
I'm telling you, this will be a successful launch. That's what my gut feeling
Master
is
enable
telling me.
issued.
T minus 2
Issuing
minutes.
watchdog.
The frost is picking up. Venting is picking up.
2 minutes.
Minus 2 minutes.
AFTU's master enable is enabled. AFTU is green, ready for flight.
Copy, thank you.
Coming up on 90 seconds, let's listen into the final seconds of the countdown for Astra LV 0006.
Oh God. Finally, this is happening. A $2.5 million launcher is going to
90
launch
seconds.
today. T minus 1 minute and 24 seconds. The weather is green, the rocket is green, the range is green, and we just waiting for the right time to light
Ace,
this
at this
candle.
time, please start PSD recordings.
PSD recording started.
T minus 1
60
minute,
seconds.
guys. Whoa!
The vehicle is on internal control.
Beaker is on internal power. Venting is stopped now. The topping off obviously is stopped.
First stage tanks are pressing.
They are pressing the tanks now, getting
45 seconds.
it pressurized and ready for ignition. T minus 39 seconds. Okay, okay, is happening. Okay, let's
First stage is at liftoff pressures, 30 seconds.
T minus 30 seconds. T minus 20,
20,
19, 18, 17, 16, 15,
15.
14, 13, 12, 11, 10.
Water on, 10, 9, 8, 7, 6, 5, 4, 2, 1.
Ignition
Ignition, 0,
and
abort.
oh.
Back at idle. Port hit.
Looks like an abort was called at T0.
Okay, guys, F's in the chat.
The team
F's
will
in the
look
chat
into
right
the
now.
issue and we will hopefully make another attempt.
Tango, confirm LOX tanks are venting.
LOX tank is venting.
It felt like it was taking a bit longer than expected. Was looking like that. F's in the chat. Oh man. Okay. I guess we'll have to. I don't see this.
Tango, confirm igniters are off and everything is in idle.
I don't think so. They can recycle it
Igniters
again
are
this
off.
time because it was an hot fire abort. Rarely it happens that someone recycles after a hot fire abort.
Confirm vehicle has gone back to GSE power.
And work.
T minus. Okay, 21 seconds they are recycling. I don't think so it will be recycled.
And abort called right near T0. Teams are currently working through their abort procedures and we're standing by for word of the next attempt.
Problem is that it was an hot fire abort. I don't know how it is built up, but for most of the rocket, hot fire abort means now you have to
Vehicles
wait for
on
the
GC
next
power.
launch opportunity.
And Tango, please deactivate launch machine at this time.
Deactivated.
Okay, going from abort to recycle checklists at this time. Odin, you are good to pull logs.
They are recycling it though. That's a standard procedure also. Before concluding anything, they need to recycle it to a proper clock first of all, and then they need to decide whether they have to go up with the launch. If it was it was not a problem with the engine and it was like kind of, you can say, a pressure related issue, right? When the pressure related issue in the what should I say, the tanks or something like that, then they can kind of recycle. But if it's an engine issue, igniter did not work properly, or there was something more major, I don't think so they will recycle. Most of the time that does not happen. After hot fire we get any recycle, but let's see. They said yes, we are going they will be coming back. Right now we can't conclude obviously we comment it right now and everything is speculation. The mission control team knows what actually happened, so if it is not a major thing, they will go on with the recycle. But obviously they first of all need to follow the procedure to save the rocket and go to that recycle point, and then decide whether they need to go on with the launch today. Any guesses, guys? What would have happened? Let me see if there is any update as such. If there is any update, they should say it on the stream only. But nevertheless, let me just see if there is any.
So it sounds like the abort was called by our guidance system near T0. It looked like the engines successfully lit, but the guidance system called an abort. The team is looking into the issue, and we will hopefully recycle, and we will begin our recycled attempt at T-minus 15 minutes at the top of our terminal count.
Oh,
Just a reminder, there is a fair bit of time in today's launch window, so plenty of time for the teams to work through this issue and work towards their next attempt.
the stocks have fallen because of that, but as they said, it's not a major issue. It's a guidance system issue. So they were updating the guidance also, right? And I mean, software configs of the guidance. If there is a software glitch, there is a software issue. Obviously, they can just deal with that. They can just put in those new configs and then launch it again. We'll have to wait and see. But right now, they are aiming for recycle. So let's keep our hopes high again. Maybe there was a plane in the range. No, there was an issue with the guidance system, as they say. Yes, this is a good time to buy if the stocks are crashing, because ultimately they will be flying it to the space, and whenever they will fly, the stocks will rise up. So yeah.
This is LD on countdown. We're going to scrub for the day.
Okay.
Thank you, everybody, for following along. But we need to investigate the misfire and attempt to make another go around tomorrow.
RCO copies.
All right, and as you've just heard from our launch director, we are going to stand down for the day to troubleshoot the abort that was triggered at T0. Our window does continue until September 11th, so there's plenty of time for us to try again. And we'll announce our next launch attempt on Twitter, so make sure you're following us at Astra. Thank you so much for joining us.
Yes, thank you, Astra, for allowing us to share today's webcast, today's launch attempt with everybody. And thank you all so much for watching. Stay tuned for coverage of the next launch attempt after the teams are able to complete their investigation of today's abort and see when the next attempt may be. But stay tuned for future spaceflight news coverage. Carolina, thank you so much for joining me today.
Thank you, Thomas.
Absolutely. Until next time, we'll see you then. Thanks for watching.
Okay. So that was it, guys. Yeah. Just a sec. Let this thing. Okay, so guys, that was the thing which we just saw, and it was not a good one for all of us. This rocket which you are just seeing did not lifted off from the pad. There was an hot fire about which happened, and we were just yeah, that happened. So we'll surf through the Twitter and see what actually happened. Other than that, one wonder, if you have any questions, you can certainly ask me. Have a look. The statement is guidance system cold and about, so I have no idea how they would get down to guidance. But engine is spinning up the engine, but electrical glitch rails. They'll come back tomorrow. Cool. As the man said himself, guidance system, that was the thing which I was also kind of, you can say, thinking in my head, but was not sure about it. Let's see. He didn't get a launch today. Rocket update. We are standing down from we still September 11, and we. Okay, guys, this is a biggest thing which actually happened. Milestone achieved. Our NASA Webb Space Telescope has completed testing ads and is being prepared for shipping it to its ESA spaceport launch site in French Guiana. This looks so cool. The second best engineering marvel after the space stations. Wow. The constructions and everything is actually done. This is the major milestone which they have achieved for JWST, and now this will be shipped to the launch site. Then at the launch site it will be tested again for the loads, the physical loads, the stress, as well as the subsystems of it. We'll have some time, but yeah. What actually happened there? Did it even ignite? So we can actually see the fire happened there, which means there was some sort of ignition. But just after that, there was uh, abort. So usually at hot fire abort, we don't get to see the um, recycle. So the next thing which is coming up is the commercial resupply station. Why do we have a dragon? Yeah, normal dragon. So we have a SpaceX launch coming up tomorrow after so long. SpaceX will finally be launching their Falcon 9 rocket. It feels like it has been eternity since SpaceX last launched. Not been like it's like it's been few months since they have launched. So it would be very interesting to finally see Falcon 9 being launched tomorrow. So let's see if I'll get appropriate time. I would stream this also, but I'm not so sure about it. There's some exams coming in and I have to study for some. Talking about some of the questions. Do we have anything? Seems like there are some children on the chat. Okay. T minus 10 hours to the CRS 23. Try helium. Hmm. Yes, I think that will be managed by the admin mods. So don't worry them. Spark plug vent. Ooh. uh, they don't use spark plug. They have a igniter. Hopefully, PTAB only. Longest gap between Falcon 9 launches in the last few years. Exactly. It's been like 3 months or 2 months already. Before they launched. The last mission they launched was what? Don't remember, but let's see. When did they last launch? We write SpaceX and SpaceX channel does not come up. This is what they have done. There are so many channels on SpaceX. So we had the Transporter 2 mission, which happened July 1. So it's July, August, and almost 2 months. Yes, it has been almost 2 months since they launched. This has to we actually had to wait for such a long time. I am very hopeful that they, utilized this time in doing some thing the Starship, and which we have seen the progress also. Okay, I guess that is the thing. We had the abort, unfortunately, and I guess that is pretty much about it. And if it happens tomorrow, I will definitely stream it. If you have anything else you want to discuss, you can do that. I'll try to answer them. 17 years now. Okay. Maybe battery contact problem, jump leads required. Could happen. Could happen. A contact problem could happen. See, uh, there are vibrations which occur when the ignited, but everything is tested to handle that requirements. The battery problem is not a thing, and they said they had a problem with the guidance navigation system. So we'll have to wait and see what was the actual problem. Thanks so much, Lois Smith. And I guess that's pretty much about it. So we had a beautiful view for today's launch. Everything was looking nominal. We got to learn about this Astra space company and the Astra rocket itself. It's a pretty good company and is aiming for a very different market. The electron is also aiming for one market, but Astra is very much you can say straightforward towards their markets. CubeSats, small sats, 25 kilograms to 100 kilograms load weight, and they haven't achieved the orbit yet properly. We are expecting them to achieve the orbit this time. So let's keep our hopes high. Let's be optimistic and let's hope that it was nothing serious and they can recycle it and we can have a live stream again tomorrow. So thank you so much all, and thank you so much my moderators, my Patreons, my members. Thank you so much, so much. It's been an honor, uh, serving all of you and Patreons and my members, YouTube members. Thank you all for supporting me. You guys are great. And until then, this is Priyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and